okay? Now, because none of us, not even me, can imagine this situation, what we're going to do is we're going to use a metaphor to try to figure out what this actually does for us, okay? So, if we were doing this in class, I would make my whole class go outside and other dimensions, yes. Now, check this out. I would make my whole class go outside and we would take out a giant sheet. Because what we can, if we can't imagine this for our three-dimensional universe, what we can do is use a metaphor for a two-dimensional universe, okay? So imagine a two-dimensional universe where left and right exists and forward and backward exists. So which direction does not exist in that universe? Which direction does not exist in a universe that only has left and right and forward and back? Which one's missing? Up and down, yes. Up and down is missing. So that universe you can think of as just a big old sheet, okay? It's just a big old sheet. And like I said, if we were doing this in class, I would get the whole class to come out and hold the edge of this big old sheet that I have. It's like I have this giant, like, 40-foot sheet that I make everybody hold around the edge. And you have to pull it really tight so that there's no wrinkles in it, because a wrinkle would be an up and down, okay? So imagine that we were holding this sheet perfectly flat above the ground, okay? Now, imagine that I took a tennis ball, okay? Imagine I took a tennis ball, and I set it right here on the sheet, and I gave it a flick. Like I just went, I just rolled it that way. I rolled it that way. What is its path through this universe gonna look like? Is it gonna zigzag like this? No. How is its path gonna look on this universe? How is it gonna roll on this universe? What will its path be shaped like if I just flick a tennis ball on that sheet? What shape would the path be? Would it be a curve? Would it curve? Ignore the circles on this sheet. Imagine it's just a big old bed sheet. It's just a big old bed sheet with no hills. So if I roll a ball on it, it will just go in a straight line. It will go in a straight line. Again, ignore the circles on here. This is just a flat sheet. It's the same thing as if you took a ball on the floor and just roll it. It's just going to go in a straight line. Okay? It's going to go in a straight line. So that's the same thing in our universe as if you were way out in the middle of nowhere, like no planets are around, there's no stars around. If you were floating in space and you threw a tennis ball, it would just go in a straight line through space. Okay? But now, at this point in the explanation, what I would do is I would, without any of the students noticing it, pull out a surprise bowling ball. And then I would come rushing over like I was going to throw the bowling ball at the edge of the sheet. And then I just, whoa, and then gently set the bowling ball in the middle of the sheet. I set the bowling ball right here, okay? Now, what's that bowling ball going to do? If they're all holding that sheet perfectly flat up in the air, and I put a bowling ball in the middle of it, what's the bowling ball going to do to the sheet? If I set a heavy thing in the middle of the sheet, what's going to happen to the sheet? It'll pull down, right? It'll go from this to this. There's the bowling ball in the middle of the sheet, okay? Ignore these words down here. I just need the picture. The bowling ball in the middle of the sheet has caused the universe to bend, okay? But here's the important thing. This mass, this is a mass, this bowling ball is a mass. Which direction is it bending the sheet, okay? Which direction is it bending the sheet? Up, down, left, right, forward, backward? Down. It's bending it down. But remember, at the beginning, we said that up and down are not a part of this universe. This universe only understands left and right and forward and backward. That doesn't mean that up and down don't exist. It just means that it's not part of that universe, okay? It's just not part of that universe. But now the universe has been bent down. The people in that universe would not be able to understand that that has happened, but it will definitely affect them. Because now, here we go, now, because the universe is bent down, there's a hill here that nobody can see. Because number one, it's invisible, and because number two, they don't understand down. But check this out. What if I took a tennis ball now, right here, and I flick it? I tried to make it go in a straight line like this. What's going to happen when that tennis ball gets close to this dip? What's going to happen? Is it going to be able to go in a nice straight line like before? No. So what's going to happen? It's going to end up curving its path, right? It's going to end up curving now. So instead of being able to go in a nice straight line, like it could when the universe was perfectly flat, where the mass is, because it's downhill in that direction, the path will curve around that object. And if you go fast enough, it'll just curve a little bit. But if you go in just right, it might end up circling that, and eventually it'll come to rest on the surface of the bowling ball. It'll roll down here and stop on the bowling ball. So what does that look like? If things are if from the point of view of people in this universe, it seems like for some magical reason, everything is attracted to the bowling ball. What force does that look like? What does this look like to the people in the universe? It looks like there's just a bowling ball there and everything is attracted to it magically. Yeah, that's gravity. So right here, this is like a planet, and everything around it is attracted to it because space is bent in a way to make space downhill. So this is what gravity is. Gravity is caused by the bend in space around an object that has mass, okay? So bent space is gravity. That's what gravity comes from. And check it out. According to Newton, what did we say happens to gravity as you get closer and closer to a planet, for example? As you get closer and closer to a planet, what happens to the strength of gravity? It gets stronger, right? But can we explain that over here? Well, check out the bend. Check out the bend here. What happens to the steepness of the bend as you get closer to this bowling ball? What happens to the steepness of this bend as you get closer to this bowling ball? Does it get more steep as you get closer, or does it get less steep as you get closer? It gets more steep. It gets steeper, right? It gets steeper. So if you were trying to stay away from this planet and you were right here, it wouldn't be that hard. But if you were right here, because the space is really steeply bent, it would be harder to keep on that hill, right? So you would be more naturally inclined to fall towards the bowling ball. And check it out. What would happen to the bend in space if we replaced this with an even heavier bowling ball, an even more massive bowling ball? What would happen to the bend in space? Would it be bent steeper or less steep? It would be steeper, more bend, right? And that means that the bowling ball with more mass would be producing more gravity. The bent space is the gravity, right? Now, with this in mind, here we go. What if we replaced this bowling ball with a black hole? Well, the black hole has infinite density at the singularity, so what would happen is it would bend so much that it does this. The bend gets steeper and steeper and steeper until you hit the event horizon, and then it just keeps getting steeper and steeper and steeper and steeper. So what have we created in the universe right here if we put a black hole right here? What have we now created right here? That's a hole, right? That's a hole in the universe. Essentially, a black hole has just bent the universe so much that it gets so steep near the black hole that you would need to go the speed of light to get out of that never-ending hole. Does that make sense? So you can't get out because the hole goes forever. If you go too deep down the hole, you're stuck forever. Now, here's the important thing, though. Remember, the black hole has bent the universe in a direction that's not part of the universe. And so that's why we can't see the actual hole that the black hole makes, because it's bending it in a direction. It's bending our universe in a direction that we can't understand, okay? This is a metaphor, okay? And oh, by the way, some of you guys mentioned this. Orbits work when things circle the drain, okay? Orbits work when things circle the drain. So if the sun is producing a big bend in space, the planets orbit because they're circling around inside of that dip. And Mercury has to orbit faster because it's steeper where Mercury is. Yeah, we're just circling that drain. Yeah, we're just circling that drain. Now, you might have done something like this if you went to like a science museum, or sometimes they're in the mall. They'll have that big funnel with the pennies, right? You could put a penny in the funnel. And what does the penny do? It kind of goes like this. It simulates an orbit. But what will eventually happen to the penny in those penny funnels? What eventually happens to the penny in the penny funnels? Yeah, they eventually go down. They eventually go down. And so somebody asked, is the Earth gonna eventually fall down the drain? Well, the answer to that is no, because this doesn't work the exact same way as those penny funnels. Because, check it out, in the penny funnel, you've got a penny rolling on plastic. And because there's friction between the penny and the plastic, that friction robs that penny of some of its speed. So the penny slows down and it loses energy, and so it gradually gets closer and closer to the drain. Is there friction between the Earth and the nothingness of space? Does the nothingness produce friction? Remember, the nothingness is nothing. So is there friction between the Earth and the nothing? Well, I'll go ahead and tell you, no. No, there's not, right? There's not. So because there's no friction between these planets and the universe, they'll be able to circle the drain at wherever their orbit is forever. Unless something comes along and robs energy from a planet, like if something outside of our solar system came in and robbed us of energy, we're going to just continue to circle the drain in the same place forever until the sun dies. But you know what I mean. So the planets will just stay orbiting at whatever place they're at, unlike the pennies. Okay, so here we go. If we go back to this picture right here, the first result of general relativity is that mass bends space. And what you should write down next to this is that that creates gravity. That's where gravity comes from. Mass bends space, and bent space is gravity. Okay? And just like we said, if you have more mass, you bend the universe more, so you create more gravity. Okay? More mass bends space more, so you create more gravity.